Juergen Allgayer from Google. Juergen is responsible for Europe, Middle East, and Asia at Google. He is a peer of a very good friend of mine, James Whittaker. He's also test lead at YouTube, and as opposed to many Googlers, he has been with Google 3 years now, and previously he was with IBM. So one of the questions we of course ask ourselves is, how is it to be a Googler compared to be at IBM?
That's a different talk now.
That's a different talk, okay. Okay, Juergen Allgayer.
Welcome. So let me start, I think, with a correction. I'm not responsible for Google EMEA. I'm responsible for something I will talk about in a few minutes, for one function within Google in EMEA. Just so I don't get the wrong job offers here. I wanted to start with a show of hands here, because I have honestly no read of who I'm talking to. So if I may ask you, who of you are active open source developers? Okay. Who of you are non-open source but active developers? Okay. How many of you are students? Okay. Now it remains. So is the rest of you in the marine segment looking for solutions for? Okay. Good. Good. That helps. Thank you. So let me start with a summary. Most of this you have already mentioned. So I have a tradition in managing software teams for about 20 years. Done this in IBM with rather large organizations. And 3 years ago, I joined Google because they offered a job that was just perfect for what I wanted to try out. Google started a group, a function called Engineering Productivity. The mission of that group is to do whatever it takes to make the productivity of the engineers in Google as high as possible. So if that means we have to build tools for them, we build tools for them. If that means we have to educate them in some technical topic, we do that. It means building infrastructure across the various locations of Google. It means speed up the compile times, it speed up the transportation time of object files, whatever we could put a finger on that says, oh, if we fix this, would shave off another, whatever the unit is you're talking about, of the overall process, and by that reduce the cycle time we have to get new versions out of the products, we would step up and try and solve that problem. So we called that group Engineering Productivity because that was the scope. It's a group all over Google, and I came to Europe in Zurich to head that group for the locations in Europe, which are about 10 engineering locations we have. That's the day job. The night job that I took on about half a year ago is I do that same role, not for a region, but for a product of Google. So for YouTube, I'm trying to solve that problem, to help them get their engineering speed up to more every time we look at it. Something is always there to be found, to improve, and reduce the time. YouTube is now shipping every week a release. Wednesday is the holy day. We start morning at 9. By 6 o'clock in the afternoon, we are at 50% on all the worldwide servers. It happens every week. The content of what we ship varies. Sometimes it's mainly bug fixes. Sometimes it's feature. Whatever is ready Tuesday night in the review goes out. All right, so what am I here to talk about today? I'll try to give you a bit more insight in what engineering productivity function does. And this is obviously around open source. So in that setup that we've been building up over the last 4 years, where in that stack do we use open source? And it will turn out that there's quite a large portion of open source used in that infrastructure that basically hosts all development of Google. So if you look at any individual service that you see in Google, Gmail, Docs, Maps, Earth, wherever you look at, you can claim that it's built with open source because that's what hosts the stack for the engineers. Right? How are we doing? So, what does that mean? How big of a load is that? And this one mainly is here to motivate that, my opinion, if you use the open source components, put them together with your own bits and pieces that you have to build to make it fit into your world, you can end up with a system that is stable, is secure, is high throughput, and can respond to the highest requirements there and the highest needs. How did we do after 3 years? What's the grade we give ourselves in doing that? And what are we doing? What are we looking at going forward to do? All right. So this is a summary, I think, of the various functions that we try to put under this umbrella engineering productivity. Right? There is some testing going on, although Google doesn't really have a QA organization in that sense. We try to get as much of the tests automated. As you will see later when the numbers come, right? The data that we look at the system, there is so many builds and tests going on and so frequently that anything manual gets you out of, I want a weekly cycle. If you have to start thinking about doing a lot of manual tests, you're almost out of that window from the start. We have a lot of work in the localization, internationalization, translation segment, because if you have that, if you want to support that speed of weekly releases and you want to do them on an international base with translation, you have to figure out a way to translate automatically, or at least semi or even higher amount of automation. And obviously provide tools that are stable enough for engineers to, very early in the game find out that they will be internationalized, that's easy to localize, etc. The largest part of the team is concerned with building tools around how to optimize build times, what to do to optimize the distribution of the builds. Right? Probably all have heard Google works on one code base. That is still true. I don't know the total number, in a worldwide set network. So we have labs in Japan, we have several in Europe, we have several in the US, we have some in Sydney, some in Australia. So we are around the globe, and at any given point in time, someone compiles something that at a different location someone needs as a dependency. So the question is, how do we get these pieces distributed over the network as fast as possible, push them as closely to the engineers as possible, so that when they start the next build, the files are already there. What we do not do in this team is the really low-level stuff. So we are not responsible for the data centers, for the wiring between the data centers, for the network on that low level. What we do though is, if you look at the stack, so I'm going to build up a high-level model of the stack of software componentry. What we do is, in the data centers, run and also maintain the software that is there, which is the first example of open source. We started probably 8 years ago now, 9 years ago, with a version of Red Hat at this time that we adopted to a self-made PC, componentry off the shelf, put together on racks, and the Linux kernel optimized to do exactly those things that we need them to do, and nothing more. On top of that is build a layer that allows for distributing your object files so that you can run them in parallel. You don't have to as a developer, you don't have to think about how do I distribute, how do I replicate, how do I do failover. This is all pushed down, taken care of you once and for all. On top of that API, if you build your application, the only thing that you have to be aware of when you design and implement it is to say, be aware that at any point in time you will be killed. It happens very frequently, because if any of these many thousands of CPUs that exercise any process. If load goes too high, has to rebalance, processes are shut off. So in the implementation and design, you have to be prepared for that. At any given point, you can be shut off. So you have to be re-entrant, you cannot have state in the process, etc. As long as you adhere to that, you can run on that platform and never care about which data center am I running, how many parallel instances of my process are running, what data am I using, etc. A lot of the compilers and or in general the programming languages we use have some adaptation to make sure that this really works out well and fast. On top of that platform, of that layer, we build also our tools, on top of which then the individual services or products or whatever you want to call that we offer the users is built. And that's the statement I made before, right? In that respect, you can think about anything that comes out of Google to be built on with open source componentry. I've highlighted here a few areas where we do use open source and a few that we build ourselves. So obviously that network that runs, that combines and connects the data centers, the distribution logic, all of that is self-made, very low to the wire, and you need to know exactly what's going on. But then, as you see almost everywhere, there is open source aspects to that. Either we brought something in that came out of open source and we keep backfitting, so we're still producing libraries to C++ compilers and a lot to Apache, etc. Or the big blocks up there where Android and Chromium is there, where we created something and then pushed it out for general use in an open source setting. What I'm specifically responsible for, and we'll talk about a bit later, is the part here about the test tools and what's called TAP, which is an application automation platform for tests that we also are pushing out. Part of them as part of Chromium, others freely available for any platform or any browser. So that was too far. So how are we doing? What's going on? And I call this a day in the life of a typical engineer in EngProd, in engineering productivity. What's happening? As I mentioned before, it's one code base with very few examples. Android has a few segments where we are co-developing bits and pieces with partners just before new releases that are carved out, where not everyone has access for copyright purposes. But in general, it's a true statement that there is one code base where about 24,000 engineers have access to. Everyone can read anything. There is no grouping or hierarchy, or you get LDAP filters for this part and for that part. You can go in, look at something. We have what we call the Boy Scout rule, right? You can go in any code, but if you see something that's not right, fix it. Leave the place cleaner than you found it, right? So in a way, everyone might happen to run into your code and go submit a few CLs, submit a few code changes, and kick off one of the 65,000 builds that we run every day, right? So in general, we try to achieve that every submitted piece of code that you call a complete change as a logical unit, when you commit that to the code base, it will be compiled. It will pull in all the dependencies. We take good care, as much care as we can afford, to make sure those are clean, because we don't want to rebuild and retest a lot of not necessary things. So once those builds are out there, we will populate a set of machines and automatically determine which tests have to be run for that, start running those tests, and feed those results back to the engineers who submitted the code, right? So you have, if you look at these numbers, at any point in time, several builds running. And it has become quite a new challenge from a UI usability point of view to help our engineers through the fact that now they get feedback on tests that came from a way back, or they came from a different branch while they're working their way through the code, right? It's an interesting aspect of this. So there's a lot going on. Specifically also if you look at the quite large number of CPUs we're using, it's not really clear at any point in time where on the world your code is just executed and built and pushed out, where your tests are running, right? So we run, if I go to the next one, so this was the part of the engineer. This is the part of those people who care more about validation and testing. On top of those builds that I mentioned, we have about 120,000 test suite exercised every day. As I mentioned before, most of them, about 110-ish, 10,000 are executed automatically. You don't have to set anything up. Well, you set it up once for your componentry, and then you go and you get the feedback. Each of these tests is trying to predict or be prepared for almost any questions you may come back to ask of what just happened here, right? In the good cases, no one cares. But if there is a bug found, everyone is all over the place. Okay, so what happened? How do I trace back? What set of data did you use? Where did it actually run, etc.? So we dump with each of those test runs lots and as much data points and signals as we can figure out might be useful later on for going back and understand, and store those on the site and have a separate set of tools that allows you to go back, mine that data, put statistics out, etc., build reports. As we went through creating those tools for that type of rather rapid development environment, these were kind of our guidelines or things we learned out of this, right? We wanted to provide an environment where tests can be run as soon as you think you have your code ready, right? You submit the code, you should get feedback as quickly as possible about known tests and what the impact is of your change. Especially because you may or may not be aware what impact, side effects your code has on components you haven't even thought about, right? Which pull in your tests, which pull in has dependencies on your code you were not aware of. If that's the case, tests that exercise that other part of the code will be run and you will be notified, right? We try to push a lot of those builds and tests into a code before you actually submit. We set up pre-submit queues so that even as you're getting ready to really deliver your code, you're notified as well as we can to say, this will probably not break anything, go ahead. We push the code out to, we have a standard matrix of platform browsers, componentry that we run our tests on. These are all out there in the cloud and are exercised with any of these runs. So for the time, the design of the tools, the top requirement in our mind was speed. Right? If it doesn't come back fast to the developer, to the engineer who submitted the code, it's not really worthwhile. Sorry for that. It's not really worthwhile, right? If it's too far back, even a day or two back, oh, there is a bug report of a piece of code I did before the weekend. This is way too far back. It has to be as immediate if possible. The way we provide the feedback has to be right? So it has to be easy to understand, easy to track back, provide all the signals, information, data points that is needed to understand it. And it has to be simple. As soon as it gets complicated, engineers will not use the tools, right? And then no win at all. A lot of cost to get here, and no one will use it. So that was the scenario, that was the task, if you want. How did we do? So as I mentioned before, there is no real QA department, so there is not a scenario where you say, okay, we think we are ready to release this piece of code. Can we have a group of testers come in and tell me that, yes, we can go, right? The testers are pushed to the left, as I like to call it, as early as possible in the engineering cycle. agile environment. And tests are built way early, starting with unit tests, middle-sized tests, all the time run. We have made pretty good headway, I would say, in test-driven development, where you start with writing the tests and then try to create the code to prove that, yeah, if this is what I need to do, this code does it, and I'm ready to go. To try and prevent the engineers from creating code that's not really needed. But we are not 100% there, but we have made good progress there. There is a lot of instances where we go in and help the groups to deal with questions about testability. How do I write the code so that it becomes testable more easily or in an automated manner if it isn't right away? So we go in to restructure the code, refactor the code. And numbers speak. So what we did a few years ago was look at different typical categories of usage of the system. So we looked at rather large C++ and Java compiles, and also rather small ones, because we thought this would give us a good overview, right? So we looked at the C++ files, and this is a snapshot from early 08 to late 09, so it's about 2 years. We went from typical hours where engineers were waiting on their result, right? So this is the summary of time waited for results of compiles over all of Google, right? And you can see before and after, it goes dramatically down. The biggest part was on the C++ side. And if you do some back of the envelope numbers, this is about 600 engineers. So after an effort of 4 years, we have maybe 300 people in this group. That's what we think, right? And the 600 engineers we get every year back, right? So I think we earned our keep, right? The same if you look at the test side, everyone knows this, right? The later you find the tests, the more expensive they get. Again, back of the envelope calculations of how many tests we run, what we typically find, how many we find in the field, etc. I think it's about the same number of engineers saved there again, just by finding the things earlier, and even without a need for human work in that. So being there, having made a lot of use of open source, what do we think is next? So this is where we came from, or where we are right now, right? Lots and lots of little stars that says, here is open source we used, or open source we created and still use ourselves. After looking at this 3 years and building it up for the last 3 years, I would say that very easily I recommend to anyone that if that is your job and you want to build a large system and you shy away because you think open source components are not stable, they won't support the load, right? They're just not the right thing. I think we have a counterexample, right? It is working. It's working on a pretty high scale. I don't know many operations of that size that are out there, and it works. It works very well. In terms of open source and what's Google's role in open source, it's a bit like what Mark was talking about in Microsoft. I think we cover pretty much the same topics. So if you talk about infrastructure, we have an overlay of fonts here. We have a lot of projects that we host at code.google.com, which is just a download site and a project host site. About 900 projects, 20 million lines of code, and there's underneath that is a list of what some of the larger ones are that you may have heard about. Quit, the Google Web Toolkit, allows you to relatively easily provide browser-independent applications or websites. It goes across. V8 was a very big one that we had released with, it was actually the reason we started the Chrome development. We thought JavaScript-based websites are way too slow, and no one was actually working on this. That has changed once this was out. Now Firefox, everyone else, Safari, even IE has caught up, has improved dramatically the engine underneath. So this is all good stuff. The second part is on the compliancy, so we host lots of patches and mirror packages to make it as easy as possible to get the latest and right set of tools. We support in various ways, with money, with people, with man hours, with woman hours as well. All of these, and probably some more. These are the better known ones. And the last part, I really am pretty proud of that we do this. We have realized that education for open source is really something that should happen quite a bit, and more and more and more. So we started, I think this is in the 7th year now, a while ago. I think it was 2005 when we started this. Summer of Code, it's a 3-month duration where we go to students, pay for their time. Sometimes they come on site. They have to write open source code, so either work on existing open source components or try and create new ones, go through the whole process. It is 2005. Now I find my line. And so what we hope is we help create more and more open source developers who know the context, so when they get ready for real life, they hopefully know what to do, how to do it, and who to do it with. So that was targeted for university, college age. And then a couple of years later, we thought, well, how do we push this earlier, right? Forgot who had said it yesterday. When you get them with 25, it's way too late. You have to get them when they're 8, right? So this is not quite 8, but it goes down to high school, 13 to 17, where it's much more task-oriented. So the students are paired up with mentors from open source organizations or groups who know how to develop in open source. So they're one-on-one paired up. The tasks are really as bite-sized as possible. And then they together work through that and solve it, and hopefully in that relatively early stage where development experience is not always present, get more and more into the right way of learning how to develop software. We also get them used to the typical payment units, which is t-shirts and pizza. There is small prizes to get. I think we invite the top 5 to Mountain View headquarters and wine and dine them for a day, and it's, well, not wine in that age group, but pizza and milk, I don't know. Chocolate, syrup, I don't know. Try to get them in the right setup, right? And it's been very well picked up. We usually have way more applications than we can actually keep pace with. The problem is more to get the right numbers of mentors than it is to get the right number of students, right? Because we want to keep that pairing going. But I think it's the right way. Start early, even earlier, right? And find the right setup of how to get people used to not just programming, but programming the right way, which in my view is the open source way. Back to my own area, so in the engineering productivity / test area, there is also quite a list of tools that we offer. So if you are web site developer and you are working on say JavaScript-based websites and you use the right browser, then you get for free, included in Chromium, a set of development tools that you can use that makes a lot of these tasks easier, right? So debugging in JavaScript, reduction of JavaScript based on a bug that you have, automation of tests, starting from click, 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 click to generating a script that can be automatically run. And it's all part of the Chromium browser. So if you start there to create your sites, you can get all these pieces integrated and for free. There is a few more. Script cover is one where we try to help you figure out the coverage, test coverage state of a given website or web page. DOM Snitch is a pretty recent one. It's the first that we have pushed out. It's should help you to get a better grip of the security aspects of your website. Right? There is a well-known list of typical security exposures. We try to help you walk through that automatically, partially automatically, so that you can raise the bar of where you think you are with respect to that topic as you deliver those sites out there. JS unit is old, etc. What we are thinking about for the future is to complement what we have now with the hosting of the source, where you can store your projects and your source code, to provide some of the services we use internally for automatic build and automatic test application together with this. So you can end up with a real developer environment hosted someplace where you can build your code, have it built, you can create your code, have it built and tested, and all of this hosted for you. I put only one question mark there because I know that we are very actively thinking about how to do this. The next part, I put a few more question marks behind, because this is something I would like to see, but haven't found the right way to make it happen, to open up to provide general build services. We have a tremendous infrastructure on builds that we use ourselves. I think it would be a good idea to replicate that in not our internal Google infrastructure, but in the in the internet infrastructure, and offer that as a hosting service for whatever driver builds that are needed. And we have to think about how to make this happen as well. So that was a short. Yeah. I'm done. I think. It was a short intro into what Google uses open source for, the fact that we think at least that set of open source components we found and looked at and used is ready for prime time. The fact that how we contribute back, both with code and some manpower, woman power, but also education. All right, now it's my question time. No, it's not.
Juergen?
I thought I had a question time.
Fantastic. As many of you show sign of, we are running out of time, but thank you very much. Juergen has agreed to come back tomorrow, and we're going to have lively panel discussions. So I suggest we maybe have questions then and later tonight, because we have one more very exciting talk to share with you that I would strongly encourage you to join in on, because we said when we started all of this, what can possibly be the future for Malta and Marsec XL and Marsa if we succeed. And this is like answering Bror's question about the spike, the blue spike it's supposed to be, since we're in the marine and water. And we got Kurt Pedersen coming in. He is from Oregon State,